Okay, next we've got to talk about how to name ionic compounds. And this is actually not so hard. We're going to give you a little bit of a chart here. This chart is not in the lecture notes, but the lecture notes kind of spell it out a little bit better. But there is a chart in the lecture notes. Here we go. Essentially what it comes down to when we're naming ionic compounds is we have to name the cation, and then we have to name the anion. And we just put them together. The name of the cation plus the name of the anion is the name of the compound. And the cation is always listed first, so we read it just like we're reading the formula from left to right, the name of the cation plus the name of the anion. And the only place where this gets tricky is the fact that we have several different types of cations and anions. We have main group cations, we have polyatomic cations and anions, and finally, cations only, we do have some transition metals. And they are going to have slightly different naming rules. But let's talk first about how to name cations, and then we're going to talk about how to name anions, and then we're going to put it together. So here we go. Naming cations from the main group. This is so easy. You just name the element. That's all. You don't even have to say anything about the charge. So for example, sodium ion is an ion that comes from the main group, that here's a cation, and we just call it sodium. We don't have to call it a sodium ion. We just say sodium when it's an anionic compound. So Na plus is sodium. Or Mg plus, the name of that element. Sorry, that would be Mg2 plus because it's in group 2. That's magnesium. Okay, that's pretty straightforward. If it's a polyatomic ion, then I'm just going to name the polyatomic ion, whatever name it was that you memorized, that polyatomic ion. So, for example, NH4 plus is ammonium. If you just memorize that, it's ammonium. And that's the name of the cation. This is the only part where it gets tricky, and that's because it's transition metal, so we kind of expected it to be tricky anyways. The key here is that we have to include the charge. And we have to include the charge in the name because there's no other way that you or I would know what the charge is, because it's different. Because each transition metal is different. It doesn't base it on the group, and each transition metal could be more than one of our charges. So what we're going to do for transition metals is we're going to name the element just like we did for main group. And then we're going to add the charge in Roman numerals, in parentheses. So sorry if that's hard to read, but you add the charge in Roman numerals in parentheses. So, for example, if I have Fe3 plus, that would be iron, because Fe's iron, and then parentheses 1, 2, 3. Iron 3 plus is iron 3. This is as compared to, for instance, iron 2 plus, which is known as iron 2. Okay, that's what we do. Now, I should, at this point, give a little bit of a shout out. The system that I'm teaching you now is called the IUPAC system because it was developed by the International Union for Pure and Applied Chemistry, IUPAC. And they kind of sound like stick in the muds, but really in the end it's very systematic and really helpful. It used to be that there was a Latin system that was used that followed this, and you would have to memorize this. Used to be. I'm not making you memorize this for my class, but I'm going to show it to you for a reason. Silver and zinc in IUPAC don't have charges because they're always the same. I told you you'd have to memorize those. But look here, if it's cobalt 2 or 3, then it's cobaltous and cobaltic. Chromium 2 or 3 is chromous or chromic. Copper 1 or 2 is cuprous or cupric. Would you guys really enjoy memorizing these? But I'm being ironic because I'm pretty sure you guys don't want to memorize these classical Latin names. This is very systematic. Charges plus 2, I'm going to put a 2. Charges plus 3, I'm going to put a 3. Charges plus 1, I'm going to put a 1. Hey, that was pretty straightforward. So I hope you guys like doing the IUPAC. This is the latest, greatest, coolest way to do it in chemistry. The reason that I'm even showing you these classical names is that, as it turns out, sometimes some groups are a little bit slower to follow behind. So in the medicinal field, you'll still see some of these listed. For instance, if my doctor says I need iron supplement and I go to the store, they're going to sell it to me as ferrous sulfate and not as iron 2 sulfate. But they are the same thing, if that makes sense. You guys with me? You guys recognize any of these classical names? Ever had to take iron supplements before? Did I lose you all? Where's my class? Somebody say something. Oh, good. You guys are here. Anyways, the bottom line is that you do not have to memorize classical names. I want you to know what they are because you might see them, but you don't have to use them. You will be using the IUPAC names instead, and it's just the charge. It's just whatever the charge is, that's what goes in parentheses. Okay, so that's naming cation. If we look at our in-class activity sheet, section 6, give the name of these cations. This one's main group, so you just, the name of it, same thing. This one's transition metal, you'll need a charge in parentheses. This one's polyatomic, you'll need to just give me the name of that. Or backwards, if I give you the name, can you tell me what the formula and charge is on those cations? I think you can do that. But I'm not going to do it right now because we've only got 7 more minutes, and I want to make sure that we at least touch all this before we get to class on Wednesday. Okay, next, how do we name anions? And this is pretty straightforward. If I'm main group, I'm going to do the same game here where I name the element with one little difference. And that is I'm going to use a suffix of IDE. That tells me that now we're talking about an ionic compound. Suffix. So for example, an oxygen anion becomes oxide. Fluorine anion becomes fluoride. That make sense? You guys with me? What would sulfur become? Sulfide. Perfect. What would phosphorus become? Phosphide. Perfect. Not phosphoride, but phosphide. Excellent. What would chlorine become? Chloride. Hooray. I think you guys got it. All right. Next, if I'm a polyatomic ion, here we go. From a polyatomic anion, then it's going to be the same thing. I'm just going to name it. Name the polyatomic ion. So for example, NO3 minus becomes nitrate. You just memorized these, so that's not a big deal. CO3, 2 minus carbonate. No big deal. And you don't have any transition metal anions, so you don't even have to worry about that category. So if we look up here at our class activity sheet, section 6 says let's just name some of these anions. So here we go. We said that sulfur would become sulfide. You guys already told me the answer to that. Or if I went backwards and said, what would dichromate be? You might have to look it up on your polyatomic ion table, because I don't expect that you've memorized it already, but you can look it up and write that down with the charge. Ooh, that's a really good question, Danny. You're going to get lost in the H's and the I's. I just know it, okay? Here's the key. The polyatomic ions, you're always using the name as it was given in our table. With the main group elements, it always ends in "ide." So let's look at this table really quickly, and we'll discover that with very few exceptions, these will end in "ate" and "ite." H, eight, eight, H, eight, eight, ite. EM for the ones that are positively charged, but H, 8, 8, 8, 8. There are only two polyatomic ions that end in "ide. There's cyanide and hydroxide. And if you can remember that, then you'll know that aside from these two, anytime you see "ide, you're looking at the element itself that's been turned into an ion. So carbide would be the carbon anion, which would be -4, different from carbonate. The 8 is a dead giveaway that you're talking about a polyatomic with a 2-. Good observation, Danny. Thank you for bringing that up. You'll see mostly 8s and ites in here, very few ides. And that's because when you're naming them, your ides are your main groups, just an individual atom with a charge. Here. Good observation. Okay, so section 8 then says, let's name all these formulas. If you can name this ion and you can name that ion, then you can name the compound. Now you might need to know what the charge is first, or you might need to be able to tell me, is this a transition metal? Is this a main group? Is this a polyatomic? Because the naming rules are different for each of those, right? If you know that it's a polyatomic, then you better know the polyatomic name. If you know it's a main group, then you better know the main group name. If you know that it's a transition metal, then you better know the transition metal name and charge, because that's an extra part of how we name that compound, all right? So that's how we're going to do each of these. And it might help to just pick them apart like we did in this section here, section 5. We're going to have to pick it apart and say, I know that oxygen is -2, therefore I know that this iron must be +2. And now if I name it, I know that this is a transition metal, so I have to name it with the charge. And then I know this is a main group, so I'm just going to make it an ide. So that is iron 2 oxide. I just pulled apart those individual ions, and then I named it. And then section 9 goes backwards. If I name the cation and I name the anion, can you put it together and make the compound? This is a little bit harder because we're going to have to make sure that we know the charges for each of these so that we can put them together appropriately to have the right formula between the two so that it's neutral. Okay, that is it for today. I'm going to send you guys off. Again, print out these in-class activity sheets, bring them to class on Wednesday, and we will go over all of this. Do what you can before you come on Wednesday for sure, so that you can come and ask intelligent questions rather than just being like, oh, I didn't do any of it. And then we can work through some of the homework too. But this should be, we've covered everything that's in their Chapter 3 homework. You should be able to even take a good stab of that at that before you come to class on Wednesday, so we can make sure that we hit the ones that are really hard for you guys.